Welcome back, everyone. And this is my presentation on this series of practice problems of solving electrical circuit. And today we want to cover something related to circuit reduction when we are giving a mesh of resistors connected in parallel in series, and we want to reduce this to only one resistance. So this is one of my favorite question here. We want to find what is the R equivalent between points A and point B. So this is like what? This is like connecting an ohm meter between point and B, and you want to see how much you can read from this ohm meter. What is this equivalent resistance? And we'll do the measurement at the end of this presentation. So let's talk about the strategy, how you approach this problem. The first thing, you need to identify all nodes. So by numbering them, because sometimes they are not so obvious. And once you identify the nodes correctly, you can see if there is something in parallel or in series that's not obvious. And more importantly, you will see if there are things that are short-circuited. So let's look to this question. So this is basically node number one. But this point and this point, they are connected. So this is the same node. So this is node number one. And this, again, is the same point. This is here at the same point, and the same point, and the same point. You can see that all of this is just one big node. Then we will have this as my second node, and this will be my third node. That's it. So we have only three nodes because these points are all the same. This and this and this. So we have three nodes. And this is, as we'll see now, is very crucial to decide what is parallel and what is series. So this will take us to the second step. Check for any parallel, series, and or short circuit. So let's look here. Obviously, this 1 kilo and this 1 kilo, they are in parallel. Why? Because they share two nodes. They share this node and they share this node. Now, let's see here. And this is very interesting. This 1 kilo, this 1 kilo, and this 1 kilo. What you noticed here, the two terminals of the resistor is the same node. What does this mean? If the two terminals of one resistor is exactly the same node, it means that we short circuit this. So basically, if we have a resistance like this, this is one node, this is one point, second point of the R. And if I connect a short circuit here, basically this point A and this point B become the same because of the short circuit. So this is why I said identifying the nodes can help you a lot to identify things in parallel, series, or short circuit. So if a component has one node common between the two terminals, then it's short circuit. So obviously this is a short circuit. What does a short circuit mean? It means that you can take out the component and leave the short circuit. So you can take this out. Also, this 1 kilo ohm is between 1 and 1, so you can take this out. And then this also, you can take it out. So it's very, very interesting, this question, that without noticing this, it would be very hard to add things in parallel and in series. And this will take us to the last point when you deal with these questions: redraw the circuit after each reduction. So now once we removing all these three components, let's redraw the circuit without those. This will make it much easier to deal with. So look here, this is exactly the same, this resistance, but I removed this. So this becomes like a floating. I just took it out. So everything here has been completely removed with this. So now this becomes much easier to deal with. Now when you look here, You can see that clearly. Now, this is all node 1. Again, this is node 1. And this is node 2. And this is node 3. Okay. So clearly that this 1 kilo and this 1 kilo, they are in parallel. Why? Because they share these two nodes. So if resistors in parallel, you can add them. How? You multiply their values and you divide by their summation, which is 0.5. And we said that whenever you have two resistors, they are equal in magnitude. When you put them in parallel, you halve them. When you put them in series, you double them. So now these two will be combined at 0.5 kilo ohm. So now I will have this resistance. I will have 0.5, the 1 kilo and the 1 kilo, and I'm looking between these 2 points. Let's also see here. Now, this and this, they are in series. These two resistors, they are in series. Now, if there is a current going here, it's exactly the same current that will go through this one. And they share one node. They don't share the other node, so they share only one node, because this is an open circuit here, remember? So they don't share the other node, so they share only one node, and nothing else is connected to this node. So these two resistors are indeed in series, so we will combine them. So we will have this now. Now we need to identify what is this. Well, this is 1 kilo and this one 1.5. Let's again number the nodes. Okay, so here we have node number 1. All of this is 1 and this is 1. Everything is 1. Okay, and this is number 2. So what you can see here, these two resistors, exactly, they are sharing the same two nodes, so they are in parallel. So basically, I can just redraw this to make it clearer for you. So as if like you have the 1 kilo ohm here and the other 1.5 kilo ohm there, and then you are looking between these 2 points. These two diagram is exactly the same. So we want to find the equivalent resistance between these 2 points. These two are in parallel, so your R equivalent is equal to 1 times 1.5 divided 1 plus 1.5, or 1.5 divided by 2.5, which is 0.6 kilo ohm. So you can see here what looks to us a very complicated question can be easily solved once we follow these simple steps. Now we will just go and do a very quick demonstration to show the measurement of this resistance. This is the circuit that I built with all the connections and the 7 1 kilo ohm resistors and all the short circuits. Okay, and as we said, we have only here 3 nodes. So let's do the measurement of the resistance between the required points. Okay, so we'll take the equivalent resistance between this point and this point. And as you can see here clearly, it is the 0.6 kilo ohm.